Review for Module 7 through 8. Number 1. Number 1 is not in standard form. This is what it looks like in standard form. Now substitute the value. Substitute these values in place of x for each one and find your y values for each. After substituting the values and getting your y values, please graph. After you're done graphing, connect your points to make a parabola. Don't forget your arrows at the end. After looking at the graph, you can see that the domain is negative infinity to positive infinity. And the range is from 0, which is included, to positive infinity, which means it goes up. Problem number 2. We're going to move this to this side, and we're also going to move this to the right side. And we will end up with 2x squared plus 4x. Plug in the values for x that were given to you into the equation and get your y values. You should notice that these two should match, and so should these. Graph your points that you were given onto the graph. After graphing your points, connect your points and form your parabola. Don't forget your arrows at the end. You have your graph. You can see that the domain is negative infinity to positive infinity, and your range starts at -2 and goes all the way to positive infinity. Problem number 3. First, draw the situation. The height is represented on the y-axis. Time is represented on the x-axis. The skydiver gets off the plane. The skydiver gets off the plane at 5,000 feet and jumps off the airplane until the parachute opens at 3,000 feet. Of course, the skydiver is going to continue until he hits the ground, which that would be a height of 0. But the problem is interested to find out when, which is time, does the parachute open. So that means that we want to know when the height is 3,000. So we are going to substitute the height of 3,000 into our equation up above and subtract the 3,000. We will then factor out a -16 because both these numbers can be divided by 16, but we're also going to remove the negative at the same time. That'll cause for this sign to change and for this one to become a positive. Now, when I divide by -16, I end up with t squared minus 125. Since this does not have a variable, it's not going to yield a solution, but the second part will. So, taking the second part, setting it equal to 0, like this, adding the 125 to both sides, we end up with t squared equals 125. We square root both sides to remove the square, and we end up with t equals 11.18 seconds. And that means that the skydiver's parachute will open 11.18 seconds after the skydiver jumps from the airplane. Now we're going to take a look at problem number 4. Write each function in standard form. So in order to get our function into standard form, we're going to need to multiply these two factors with each other first. And I usually use a Punnett square. So I'll be back after I'm done with that. So as you can see, I've done my Punnett square. This factor goes here with x being positive and 3 being positive, and the second factor goes here on the outside with x being positive and 2 being negative. Just like multiplication tables, x times x is x squared, 3 times x is 3x, and negative 2x and negative 6. Now, we also notice that these two here are going to actually add together, so giving me 1x. So I can replace my 5 here with, and the whole green factors, I can replace them with the result from my Punnett square, which is x squared plus 1x minus 6. Now I need to distribute my 5, so I'm going to end up with y equals 5x squared plus 5x minus 30. And that's standard form. Number 5 is similar to number 4. The only difference is that this time we have a negative in the front. So I'll be back after doing the Punnett square. These two in a different color because these two are the ones that are going to combine. After looking at the Punnett square, we find out that y equals negative 2 times x squared minus 4x plus 3. All we need to do now is distribute the negative 2. So the result of that is y equals negative 2x squared plus 8x minus 6. Page 2. Number 6, since they are asking us for the zeros, all they want is the solutions. So all we need to do is change the signs. So x equals 3 and x equals negative 5. Done. For number 7, since this has a variable, that's x equals 0. And this one I would have to change the sign, so x equals 1. Those are the zeros for our solutions or roots or x-intercepts. Number 8, x equals negative 1 and x equals negative 1. Since this is repeating, I don't need it to repeat twice. Once is enough, and that's the answer. Number 9, x equals 5 and x equals negative 1. Number 10 involves factoring by grouping. So we can see that these two are actually the same. So we can write them once, and then we're going to look at what's left. So we can see that we have the 2x plus the 14 left. So those will go in here in the second parenthesis. And we will have two factors. So which, if we set them equal to 0, our first one's pretty easy, x equals 2. But our second one might be more difficult, so we could just say 2x plus 14 equals 0, and we can solve that by subtracting the 14. So we end up with 2x equals negative 14, and then we divide by 2, so that means x equals negative 7. So our answers here are x equals negative 7 and x equals 2. So our answers for 11 are x equals 4 and x equals 2. You can see that that one repeats, so I wrote it once. And then I wrote down what was left in this term, in this factor there, and giving me x equals 4 and x equals 2. On number 12, I want to talk about what would happen if this was turned over. So let's say we had 3 minus x instead of x minus 3. Now they look very similar, but what we would have to do is we would have to turn this one into a negative. And then what we could do is flip this back around so that it matches our other one. And the part in the front would stay the same, 5x, x minus 3. And now if you notice, these two will match, right? So we'll copy those once. So we'll say x minus 3, and the ones that we fixed earlier is 5x minus 25. And so our answers would be x equals 3 and x equals 25 over 5, because I'm changing this sign but then dividing by 5. So that means x equals 5. And there would be my two answers. Okay, of course, those aren't the answers to your problem. So I'm going to redo the problem now with your actual answers. So I'm going to need to erase everything here. And I'll be back in a second. Now, with your problem, these two match. So x minus 3. And what's left is 5x plus 25. So our first answer is x equals 3. And our second answer would be this changes to a negative 25. And then we divide by the 5. So that means our second answer is x equals negative 5. Okay, on number 13, x minus 7 repeats. We wrote it once, giving us x equals 7. And the second part is 3x plus 7. We change the sign on the 7, change it to a negative, divide by 3, and our answer is negative 7 over 3. Number 14, the height of a javelin after it has left the hand of the thrower can be modeled by the function h equals 3, parentheses 4t minus 2, times negative t plus 4, where h is the height of the javelin and t is the time in seconds. How long, which means that they're asking us a time, is the javelin in the air? They are basically asking us here to set h equal to 0, because we want to know when the javelin goes up, comes back down, and touches the ground, and we want to know how long that took in time. So that means that our h has to become a 0, and that means I'm only interested in this factor and the second factor because those both have variables, but I'm not interested in this 3 because there's no variable. So I'm going to solve both of these factors and I'll be back. So as you can see, I changed the sign from negative to positive on the 2, and I divided by 4. So that is one of my answers, 1/2. And for this one, I got t equals 4, but I'm going to show you how I did that. So negative t plus 4 equals 0. So I'm going to take this negative t, and I'm actually going to move it to the other side, making it a positive t. And if I add it to 0, it's just t. And on this side, I have the 4 left, so that means t equals 4. And that's how I got my second answer. Now, the thing with this problem is that I end up with the 1/2 as an answer and 4 as an answer. That means my parabola started at 1/2 and went all the way up here into 4. But I need to find out the difference between 4 and 1/2. I need to find out how much time happened. So what I need to do is I need to subtract my 4 and take away 1/2, which obviously is going to give me 3.5. So that's how long the javelin spent in the air, 3.5 seconds, and that is actually my answer. So you can see that I answered here. The javelin was in the air 3.5 seconds. Number 15, they're asking me the same thing, which means that they want me to find out the number of seconds that it took for the flare to hit the water, which means my h is going to turn into a 0. And that means that if I were to solve this problem, I change the 24 into a negative 24, and I divide by a negative 4, giving me my first t, which is 6. On my second t, I'm going to change my 4 to a negative, and I'm going to divide by 4 here, divide by 4, and I'm going to end up with my second t, which is a negative 1. Now, since time is not negative, and on this problem, it's a realistic problem, so that means time starts at 0. So whatever it was doing before that, I really don't know, at least my parabola, okay? But I know that wherever it started, it came down, and it didn't hit the ground again until 6 seconds. So from 0 to 6 is 6 seconds. So that means the flare took 6 seconds to hit the water. Here you can see that I wrote my answer. The flare took 6 seconds to hit the water. Okay, on number 16, we need to go through our checklist. Is it in standard form? Yes, it is. Is there a GCF? No, there isn't. Is there 2 terms? No, there is not, which means I do not have a difference of squares. So I go into 3 terms, which means that I would multiply 1 times 4. It gives me 4. And my numbers that multiplied before is 1 times 4 and 2 times 2. I'm looking for the pair that subtract because of this here. The sign here tells me to subtract. The ones that subtract to be 3. Obviously 1 and 4 subtract to be 3. So I'm going to circle those, and I'm going to set up my parentheses so that I'm able to factor. So I end up with x and 1 and 4. Now, when my sign at the end is a negative, I need to make sure that I'm careful with my signs. So which one is bigger? I check, and the 4 is bigger, and that one always matches the middle when this is a negative. So in this case, C is a negative. My 4 is going to match the middle, which means I'm going to have a negative there too. And so my 4 is going to be a negative, but that means my 1 has to be a positive, and I'm done factoring. Number 17. I'm going to go through the same checklist. Is it in standard form? Yes. Is there a GCF? No. Is there 2 terms? So I could check difference of squares? No. I could also check for a perfect square. So I can check if this number is perfect, which it is, but the 3 isn't. So it's not a perfect square. So I'm going to go into factoring when I have 1 in the front. So 1 times 3 is 3. And my numbers for 3 are 1 times 3. And I need to check if these numbers actually add, because of this sign, to make 4. And yes, they do. So that means I'm going to be able to set up my parentheses. Since I have 2 x's here, they split up, 1 x there, 1 x there. And my numbers that I found are 1 and 3. 1 and 3. And whenever this is plus plus, these will be plus plus. So that makes this one really simple. 19. I'm going to go through the same checklist. Is this in standard form? Yes, it is, because I have a, x squared, b, x, and c. Is there a GCF? No, there is not. All of my numbers can only be divided by 1, which means there is no GCF. So I'm going to check to see if there's a difference of squares by checking if there's 2 with the negative in the front, in the middle. And as you can see, so you can see on this problem that it is in standard form. There is no GCF, and I'm checking to see if there's 2 terms with the minus in the middle. There isn't. There's 3 terms. And so now I'm going to factor using the 1 in the front. So 1 times 24 is 24. 1 times 24, 2 times 12, 3 times 8, 4 times 6. 5 does not go evenly into the 24. And 6 is the next number. But as you can see, the 6 already comes up. The next number would be 8. The next one would be 12. And the next one would be 24, which they're all there. Now I'm looking for the pair that add. So I know these 2 add to be 25, these add up to be 14, and these add up to be 11, and the last ones add up to be 10. So I'm looking for the ones that add up to be 11, which are the 3 and the 8. So I'm going to circle those so that I don't forget them. And I'm going to set up my parentheses, splitting up my x's here and here. So my x's are going to go here and here. My numbers are next, which are 3 and 8. And it doesn't matter where I put them. So I could put 3 here and 8 here. And as I mentioned earlier, when this is plus plus, these are plus plus. And I'm done factoring. I just noticed that I didn't do number 18. So I'm going to go through my checklist again. Is this in standard form? Yes, it is. Ax squared, bx, and c. Is there a GCF? No, because all my numbers can only be divided by 1. Are there 2 terms? No, there aren't. Is this a perfect? That's a perfect, but this isn't. And now I go into factoring with the 1 in the front. So 1 times 45 is 45. 1 times 45 is 45. 3 is 3 times 15. 4 doesn't go in evenly, and 5 times 9 gives me 45. 6 doesn't go in evenly, neither does 7 or 8, and the next number would be 9. I'm looking for the pair that add to be 14. So my pair that adds up to be 14 are the 5 and the 9. I'm going to split up my x's, and I'm going to put my numbers, which are 5 and 9. And so whenever we have minus plus, when we have minus plus, then they're both minus. You need to be very careful when C is a negative. That's when our signs are different. And that's also when you need to be careful which one is the positive and which one's the negative. Number 20, same checklist. Is it in standard form? Yes, it is. Is there a GCF? Yes, it is. Are there two terms? No, so it's not a difference of squares. Is it perfect? This is, but this isn't. Now we go into factoring with the 1. 1 times 32 is 32. So 1 times 32, 2 times 16. 3 does not go in evenly. 4 times 8. 5 does not go in evenly. 6 does go in evenly. Does not go in evenly. And 7 doesn't either. And 8 would be the next number, but it's already on my list. I'm looking for the pair that add up to be 12. So we can see here that the 4 and the 8 add up to be 12. So that's my pair. And so I'm going to split up my x's and put in my numbers, which are 4 and 8. And now I'm going to check for the signs. So whenever I have minus, plus, then that means my signs are going to be minus, minus. And I'm done factoring. Number 21, same checklist. Is it in standard form? Yes. Number 2, is there a GCF? No, there isn't. All of them can only be divided by 1. Is there two terms? No, so I move on. Is it a perfect? Yes, this might be a perfect. This is a perfect because the root is x, and this is a perfect because the root is 6. So I'm going to check to see if it is a perfect. It's worth it. So x times 6 gives me 6x. Now, if I double that, I'm going to get 12. Now, what I want to do with that number is I want to check if it's the middle. And no, in this case, it's not, so it's not a perfect square, which means I'm going to go into my regular factoring, which is the 1 and the 36. So I'm going to make my list, 36, 1 times 36, 2 times 18, 3 times 12, 4 times 9, 5 doesn't go in evenly, and 6 times 6. I'm looking for the pair that add up to be 15. So the pair that add up to be 15 is the 3 and the 12. So I'm going to circle those. And now I'm going to split up my x's, just like before. And I'm going to put my numbers in, which are the 3 and the 12. And now I have a minus plus, which earlier I told you if you have a minus plus, then your signs are going to be minus, minus, and I'm done. Page 2. Page 3, more factoring. We're going to check to see if it's in standard form. It is ax squared plus bx and c. Is there a GCF? No, there is not. Is there two terms? No, there are not. We're going to check if it's perfect. This isn't because the 42 is not perfect. So I'm going to go into 1 times 42, which is 42. Or you can check quickly. If you're that quick, you can say, what do numbers multiply to be 42? But when I subtract them, I get 11. So if you're not very quick at it, if you do know, let's see. 1 times 42, 2 times 21, 3 times 14, and there we go. That's our pair that multiply to be 42, but subtract to be 11. So if you weren't quick to find those, you can always make your list. And when you're making your list, as soon as you find the pair, you can stop. Now in this case, my numbers are 3 and 14, but things change because Here, this is a minus. And if C is a minus, you need to be more careful with your signs. So I need to look at my numbers and figure out which one's bigger, the 3 or the 14. In this case, the 14 is bigger. And when C is a minus, that bigger number is always like B. So that means this one will be a negative. And that means the other one will be the opposite sign, which is a plus. And we're done factoring. On number 23, something that should stand out is that these are perfect because that's an x and that's a 9. So 9x, if you multiply them together. If you double that, you get 18x. Is that the middle? Then yes. So what we're going to do is we're going to take the root from these two, which is x and 9, and the sign from the middle, which is a minus, and square it. The answer from this factoring is x minus 9 to the second power. This is a perfect square. Number 24. Is it in standard form? Yes, it is. Is there GCF? No, there isn't. Number 3. Is there two terms? No, there are not. Number 4. Is it perfect? No, because the 44 is not perfect. Number 5. Now we go into multiplying. So 1 times 44 is 44. 1 times 44. Always start with 1, then go to 2. That's 22. Then go to 3. 3 doesn't go in evening. 4 does. 4 times 11. 5 does not. 6 does not. 7 does not. 8 does not. 9 does not. And 10 does not. So that means 11 would be our next number. We want to find the numbers that subtract to be 7. So the numbers that subtract to be 7 are the 4 and the 11. We're going to split up our x's. We're going to put our 4 and our 11. And again, we have to be careful because the last number is a minus. So that means the 11 is going to be like the middle, which is negative. And that means the 4 has to be a plus. 5. Again, going through our checklist. Is it in standard form? No, it is not. I'm going to need to move the 5x to the other side. So making it x squared minus 5x equals to 0. It's in standard form now. Is there a GCF? Yes, there is. They both have an x. So we're going to take that x out, and we're going to get x minus 5. And that equals 0. And now we can solve. My first one is x equals 0. Because as you can see, x equals 0. For our second one, x minus 5 equals 0. If I solve that, I'm going to get x equals 5. Now, if you need to see the work for that, it looks like this. And you add 5 on both sides. So that means x equals 5. 26. Is it in standard form? No, it is not. Now it is. Is there two terms? No, there are not. Is there a GCF? No, there is not. Is it a perfect? No, it is not, because the 18 is not perfect. So we need to multiply. 1 times 18, or what two numbers multiply to be 18, but when I add them, they give me 9. I know those right away, so I know that those are x and x, 6 and 3, and because my signs are minus plus, I can use minus minus, and I'm done factoring, and this side was equal to 0. I'm going to solve x equals 6 and x equals 3. If you still need extra help finding how the numbers were found, again, the 1 times the 18 is 18. 1 times 18, 2 times 9, 3 times 6, and you can see that if I add 3 and 6, they give me 9. So those were the numbers I chose. Number 27. Is it in standard form? Yes, it is. Is there a GCF? No, there is not. Is there two terms? No. Is it perfect? No. So we're going to need to find the numbers that multiply to be 50. But when you add them, because this is adding, you get 15. If you know those right away, they should be x, 5, and 10 equals 0. If you look, 5 times 10 gives me 50, but 5 plus 10 gives me 15, so it works. And my signs are minus plus, so that means I'm going to have minus minus. My answers are x equals 5 by changing the signs, and x equals 10. Is this in standard form? No, it is not. Let me put it in standard form. Is there a GCF? No, there is not. Is there two terms? No, there is not. Is it a perfect? No, it is not. So I'm going to have to find the numbers that multiply to be 21. But when I subtract them, I get 4. Those should be pretty obvious to you. So you should see that the numbers are 7 and 3. If I multiply them, I get 21. But if I subtract them, I get 4. Now, because C is a negative, you need to be more careful. So that means the bigger number has to be like B. So that means the bigger number is a plus and the other one's a minus. And my answers are x equals negative 7 and x equals 3. Check your answers for number 29 and number 30. On number 31, your first move should be to get it into standard form. Check if it has a GCF, which it doesn't. If it's two terms, it's not. And now we go into multiplying because it's not a perfect square. So we're going to say 2 times 2 is 4. Now we're using the 4. 1 times 4, 2 times 2. And out of those, I want to see which ones add up to be 5. The 1 and the 4 do. So I'm going to use that pair. But now because I have a number in the front, I change my strategy. And I put 2x and 2x and my 1 and my 4. But the signs still stay the same. I have minus plus, so it's going to be minus minus. And here I reduce. So as you can see, this one does not reduce by any number, so I'm going to copy it. And my second one, actually, I can reduce by 2. So I'm going to divide both of them by 2, getting x minus 2 equals 0. And I'm not supposed to start solving until I get to this point. So you have to do the reduction. So that means our answers are x equals 1/2 and x equals 2. Next problem. Into standard form, check for GCF, check for perfect, and check for difference of squares. It's none of those. So we're going to start multiplying. So 3 times 3 is 9. So 1 times 9 and 3 times 3. Out of those pairs, which ones add up to be 10? The 1 and the 9 do. So, and we have a number in the front. So we are going to use that number in the front for both. And we're going to put in our numbers. So 1 and 9. We're going to check for our signs. It's minus plus. So we're going to put in minus minus equals 0. And we're going to reduce. So our first one is 3x minus 1. It does not reduce. And the second one we can divide by 3. So we get x minus 3 equals 0. So our answers are x equals 1/3 and x equals 3. The next, just continue the pattern. So we're going to, I want you to check your answers after you try them. You can check your answers for number 33 and number 34 right now. Number 35 is already in standard form, but there is a GCF, which is 4. They can all be divided by 4. So I'm going to factor out a 4. Looks like this. Now, I'm going to check what numbers multiply to be 12, but when I subtract them, I get 4. So I know 6 times 2 is 12, and if I subtract them, I get 4. Since C is a negative, I need to be careful with my signs. The bigger number is 6, and that one should be like B, which is a positive. So that means 6 is a positive and 2 is a negative. That means my answers are x equals negative 6 and x equals 2. Number 36. Is it in standard form? Yes, it is. Is there a GCF? Yes, there is, a 2. When I continue for this inside here, is it a difference of squares? Yes, it is. I can split it up into x plus 4 and x minus 4. These two x's split up, and the 16 is 4 times 4, so that splits up, and when I have a minus in the middle, between two numbers, I end up with plus and minus. Of course, these two numbers need to be perfect. So my answers end up being x equals negative 4 and x equals 4. The 2 does not give me an answer because there is no variable. You need to get number 37 into standard form. This is not a perfect or a difference of squares, and there is no GCF. Now we need to multiply. So 2 times 21 all the way across is 24. Oh, excuse me, 42. And if I do the factors, I'm looking for the ones that subtract to be multiply to be 21 but subtract to be 11. So the ones that do that are 3 and 14. So I'm going to split up since I have a number in the front. Since I have a number in the front, I'm going to split up the 2x and the 2x, put in my numbers, careful with my signs, and this one here reduces by 2, so I end up with x plus 7, and then I solve both of them, and I end up with 3 over 2 and negative 7. Number 38, get it into standard form, and then check for a GCF. It doesn't have one. Check if it's a difference of squares or a perfect square. It's not, because of the 7 here. It's not perfect. And now we could either multiply, or I could show you a different way. With this method, it requires some guess and check. So I could try the number 1 and 7, because those are factors of 7. And I could try here 6 and 6. And you can see here that if I do 6 and that, the numbers are going to be too big because I have 42 and 6. And if I subtract them, I do not get 19. So that one doesn't work. So like I said, this requires some guessing here in this case. Now I could try a different pair. So I could try like 4 and 9. Now again, I could go across, or I could go crisscross here. So either way, as long as I find my numbers. So I'm going to try and like keep my numbers small. So I'm going to try the 1 and the 9, and I'll try the 4 and the 7. That's a little smaller than me going the 7 times the 9, which is a 63. It's too big. Now, there you can see that I get 9 and 28. And if I subtract those, I get 19, which is what I need for the middle number here. That is what I need, subtracting to get 19. So I found my numbers. So that means I don't need this here anymore. So as you can see, I wrote my numbers down over here, 28 and 9, because I found them. And now I go back to doing what I was doing before. When a number's in the front, I keep the number in the front for both. I write down my numbers, 28 and 9. And my signs, I have to be careful because this is a negative. So that means 28 has to be like the middle, which that means that's a minus and that's a plus. Now, this first one actually reduces by 7. So I end up with x minus 4, and 7x plus 9 equals to 0. So my first one is x equals 4, and my second one is x equals negative 9 over 7. 39, you need to get it into standard form. See here that this might be a perfect difference of squares, but I need to check if it has a GCF, which it does, a 5. Put this, and then I'm going to split up the difference of squares, and this is what it looks like. And now I have to give my answers. These are the answers. Move is to get it into standard form. There you go. We can try that other method again. So 1 and 2 are my factors of 2, but I'm going to do that over here so that it's scratch work. So 1 and 2, and then 15, some common factors that are 15 are 3 and 5. So I'm going to try 3 and 5. Now again, I could try going across, and that here is a 3. Okay, and or I could try going crisscross, which I think that'll work better. So if you didn't, if you got 3 and 10, if I subtract 10 minus 3, I get 7. That doesn't work because that's not the middle term, because you can see here that our middle term is a 1. So that means that did not work. So I'm going to try the that's a 3. I don't want to get confused there. And try going across. So if I crisscross, 1 times 5 is 5, and 2 times 3 is 6. So I have 6 and 5, and 6 minus 5 gives me 1, which is what I want in the middle. So I'm going to split up and use those numbers. So 2x, 6 and 5. My sign is negative at the end, so that means my bigger number, which is the 6, has to be like the middle. So that's a minus, and that's a plus. And I can reduce the first factor, so I'm going to reduce to x minus 3 and 2x plus 5. End up with x equals 3 and x equals negative 5 over 2. The end of page 3. Page 4. Now that I've done so much factoring, I'm going to let you practice these and check your answers. So the answers to these problems are here. You can check them. And I'm going to do number 47. 47. Get it into standard form. It looks like this. Check if it has a GCF. It doesn't. And now try the method I taught you earlier. So we're going to try multiplying 2 and 2 and 7 and 7. Now either way, if I go this way or if I go this way by multiplying, I'm going to get 14 and 14. And no way is that going to give me 100. So I'm going to try changing my 7 and my 7 into, so I'm going to keep that 2 and 2, but I'm going to change this into 49 and 1. So I'm going to try crisscrossing, so that's 2 and 98. So 2 plus 98 gives me 100, which is what I need for my middle term. So now I can start factoring. Since I have a number in the front, I'm going to keep that number in the front. And I get 2 and 98. Now, since I have minus plus, my signs are going to be minus, minus, and then I'm going to reduce from there. So I'm going to divide by 2 on this one, so I'm going to get 2x minus 1. And on the second one, I can divide also. I'm going to divide by 2, so I'm going to get 2x minus 49 equals to 0. And so my answers are going to be x equals 1/2 and x equals 49 over 2. Here are your answers for 48 and 49, and I will be doing number 50. Number 50 has a GCF, and you need to be careful with that. After you have factored out the GCF, the problem becomes very simple. You can factor it and then give the solutions. Number 51, we already did a problem like that earlier, and so but on this one you need to be careful because it also has a GCF. You also have to be careful when you factor out a negative. All the signs will change, so this first one becomes a plus, a second one will become a negative. Whoops. As I was saying, when you factor out a negative, you need to make sure all your signs change. So this one will become a plus, this one will become a minus, and the last one will become a minus. Actually, after looking at that problem, we find out that it can actually, all numbers can be divided by 8. So after factoring, we end up with negative 8, t minus 7, and 2t plus 1. And then to give the answers, we need to change signs. So t equals 7 and t equals negative 1/2. But we do not want this answer since time is never negative. And so our only answer becomes t equals 7. So it says in the problem, find the time it takes for the flare to hit the water. So the answer to this problem is the flare will hit the water in 7 seconds. Number 52 is a perfect square. That means that my first number is a square. My last number is also a square. It's a perfect square. The root of this one is x, and the root of the last one is 5y. I'm going to check if this actually is a perfect square by taking the roots, which are x and 5y, and multiplying them together and also doubling them, so multiplying by 2. So I end up with 10xy, and I'm checking to see if that's the middle number. And it is. So that means this is a perfect square. So I'm going to take the root from the first number, which is x squared, and I'm going to write the root here. So I'm going to get x. I'm going to get the sign from the middle number, which is a plus. And I'm going to get the root from the last number, which we already did earlier, which was 5y, and I'm going to put that here. So 5y, and then I'm going to add a square, and that's our answer here. Okay, since now you understand perfect squares, try the rest of them. Try the next one and see if you get the same answer. After factoring out a 2, we end up with 16x squared plus 40xy plus 25y squared. Now you could check if this is a perfect square by taking the root of our first number, which is 4, and writing it down off to the side, 4, taking the root of the last number, which is 5, and we get 20. Now double that up, so 20 and 20 is 40, and is that the middle number? Yes. So that means this works. So we're going to keep our 2, and then we're going to have a square. So the roots were 4 and 5, and of course our letters are x and y, and the sign from the middle term goes here, which is a plus, and then we have it squared. So that's our answer. 2 parentheses 4x plus 5y to the second power. 54 is a difference of squares. So how do we know it is a difference of square? We have two terms with a minus in the middle, and our first term is a perfect square, which it is. It's a 9x, and our second term is also a perfect square, which is an 11y. So now to factor this type of problem, we're going to split up into 2 parentheses. We're going to put 9x and 9x in the first spot, and we're going to put 11y and 11y in the second spot. And for our signs, one is a plus and one is a minus. And this is a parenthesis. Okay, that's your answer. Number 55 doesn't look like a perfect square because 75 is not perfect, and neither is 48. But they have a GCF, and so you're going to need to factor out the GCF. They both have a GCF of 3, which means that we are going to be, oh boy, which means we're going to need to divide each one by 3. So 75 divided by 3 is 25. Oh, I forgot, there is also an x, so we're going to need to take out the x as well. So we're going to get 25x squared minus 16 by itself with no more x. So now we're going to factor out this part, which is a difference of squares. So we're going to keep our 3x, and then we're going to factor this out to 2. So the root of 25 is 5x and 5x, and for 16 it's 4 and 4, and our signs become plus and minus. That was the end of page 4. Page 5. First, we need to get it into standard form. Next, we need to find if there's a GCF. They both can be divided by 2, and so we end up with 2 times 25x squared minus 36. We need to factor this further, so we end up with 5x plus 6 and 5x minus 6. Now this problem has an equal 0. That means we need to give our solutions. So for this problem here, the 2 does not have a variable, so that's not going to give me an answer. The next factor does, so our first answer is x equals negative 6 divided by 5. Our second answer would be x equals 6 divided by 5. And I'm getting that by changing the sign here and dividing by 5, changing the sign here and dividing by 5. Number 57, get it into standard form. They can all be divided by 2 and they all have an x. This is what it looks like. Now this problem is we're checking to see if it's a perfect. So here we have 9x, which would be 3, and here we have 16, which would be 4, and we need to check that. So we're going to do 3 times 4 off to the side. So 3 times 4, which gives me 12, but if I double that I get 24, and I want to check if that 24 is actually the middle number, which it is here. So that means this is going to work so as a perfect square. So I'm going to keep my 2x and I'm going to make this a perfect square. And so I'm going to get 3x with the sign in the middle, which is a plus, and the square root of 16, which would be 4. And so our answers here, since it has a variable, it's going to give me an answer, x equals 0. That's my first answer. And my second answer is negative 4 divided by 3. And it looks like I only have 2 answers when I'm supposed to have 3. But see, this one is repeating because it's squared. I'm just writing it once only. And this is another answer. So this one would be 2 because it's repeating, and 3, which is what this says, 3 answers. I have another problem just like the one that we did earlier, except that this is with the perfect squares. So we're going to have a perfect square. So the first thing you need to do is make the height equal to 0, like we did earlier. So we're going to make our height equal to 0. So this is going to become a 0. And so we're going to have 0 equals, now at the same time, I'm actually going to factor out a negative because I don't want that negative there. And there is no GCF, so just the negative. So we're going to take out the negative, and I'm going to have 16t squared minus 8t plus 1. So that just turned my last term into a positive, which means I can check if this is a perfect square. So the root of that is 4. The root of that is 1. And 4 times 1 is 4. And if I double that up, I get 8. And I'm checking to see if that is the middle number, which it is. So we're going to keep our negative. And I'm going to factor this into a perfect square. So it's going to be 4t minus, because the sign in the middle is minus, and the root of 1 is 1. So our only answer is x equals 1/4. So the projectile is launched from a hole in the ground 1 foot deep. Its height follows the equation. Use factoring by perfect squares to find the time when the projectile lands back on the ground. So the projectile will land back on the ground after 1/4 of a second. We want to find out in this problem which of the following are the solutions to the problem. Now it does have a GCF of 4x. That leaves me with that, but I still need to factor in 2 difference of squares. So I am going to have 4x times x plus 2 and x minus 2 equals 0. So my answers to this problem are x equals 0 for our first one. For my second one, it's going to be negative 2. So x equals negative 2. And our last one, which is x equals positive 2. So there are all my answers, and I'm going to check which ones are solutions. So negative 2 is a solution. They asked me which ones are the solution. Yes, that one is 1. Negative 1 is not on my list. 0 is. 1 is not, and 2 is. So my answers are A, C, and E. On number 60, they're asking you to write an equation of a function that was vertically stretched by 2, which that means that's our A. So our A is equal to 2. It's also translated 4 units. Now, if you remember, we always have to use the opposite. So that means our H is equal to 4, but when we substitute it, that sign's going to change. And it was also, for the K, it was moved down 5, so that's a negative 5. Now the equation goes y equals a, and then x minus h, there's that negative, that changes the sign, and plus k, and since that's a plus, that means I don't change the sign. So my equation is y equals 2 x minus 4 squared plus minus, because that's a minus, 5. There's my equation. Simple as that. So the a goes here, 2. The 4 goes here, 4. And the negative 5 goes in this spot, which is negative 5. That's your answer. Okay, on number 41, you need to identify your A, which is A equals 1, your B, which is 6, and your C, which is 3. For the axis of symmetry, you need x is equal to negative B over 2A. So you're going to have negative 6 over 2 times 1, which that equals negative 3. Now, you actually don't need to write all that down. You could do your work on the side, and the answer would be negative 3. You need to give an equation. For a maximum or a minimum, we need to find our vertex. So that means we need to substitute that negative 3 we just found into the problem. Now, I know I have a minimum because my graph opens up, which means that I'm at the bottom here, which is a minimum. Looks like I'm in a hole. So my vertex is my minimum, negative 3 comma negative 6. That is also my vertex. I know that my graph is the same as x squared. It's not narrower or wider. And I know that because a equals 1, and I don't have a number bigger than 1, or between 0 and 1, which is a fraction. So I don't have, if whenever I have a 1, it's going to be the same, because this one's a 1 also. My graph opens up, I mentioned that earlier. And to find the y-intercept, I need to plug in x equals 0. Now that's pretty easy, because if I plug in 0 here, I'm going to get 0. If I plug in 0 here, I'm going to get 0, and 0 plus 0 is 0, and then plus 3 is 3. So that means my y-intercept is 3. Now I plugged in x equals 0, so that means that my x spot is 0. So my y-intercept is 0, comma 3. In problem number 62, they are asking you for another real life word problem. So let's start here where it says consider a particular baseball player at bat. The height of the ball at time t can be modeled by this equation, where v is the initial upward velocity, which is this v here, and s is the height at which the ball is hit, which is this, the s. And if a ball is 4 feet off the ground when it is hit, that means that's our s, that's 4. And it is negligible upward velocity of 0, so that means this v will be 0 because that's your velocity. And then when will the ball hit the ground? Now they're not going to tell you what this h is, but they are telling you with words. The ball is going to hit the ground. So if we were to draw what this looks like, this is our height here, and this is our time. And this is the ground. So on the ground, your height is 0. Now the ball is starting at 4, which is your s, and then it's going to have a velocity of 0. So we know that s is 4, h is 0, and the last one, which is v, is also 0. So we're going to plug all these numbers in. So we have this equation, h equals negative 16t squared plus vt plus s. And here's what's going to happen. The s is 4. It's going to go there. So I'm going to put that there. The h is 0, which is this one. So that's going to be a 0. And the velocity is 0. So I'm going to plug that in right here. That's going to be a 0. And then everything else gets copied. So negative 16t squared plus 0t plus 4. So now what we have is 0 equals negative 16t squared. This cancels out, plus 4. Now, I don't really like that 16 being negative, so I'm going to move it to the other side. But that means the 4 is going to come with it, and I'm going to have 0. From there, I am going to move over here, and I'm going to factor out a 4. So I'm going to get 4t squared minus 1 equals 0 still. And that means that I can factor some more. So I'm going to have 2t plus 1 and 2t minus 1. If I solve, t is equal to negative 1/2, which I don't care for because it's negative, and t equals 1/2. So the answer here is that time is going to take 1/2 a second to hit the ground. So it takes 1/2 a second to hit the ground. Here we are at the last page. The height of a ball thrown upward on the moon with a velocity of 8 meters per second can be modeled by this equation, which, as you can see, the 8 meters are already put into your equation as your initial velocity from the earlier problem where we learned that v belongs in that spot, where h is the height of the ball in meters and t is the time in seconds. At what times will the height of the ball reach 19.2 meters? So here they want the h to be 19.2. So we need to put in 19.2 as our h. We're going to go negative 0.8t squared plus 8t. So first of all, we need to get this into standard form. So I'm going to move the 0.8 over to the other side. So I'm going to get 0.8t squared minus 8t plus the 19.2 that's there equals 0. Now, the next thing I'm going to do is I'm going to move the decimal over one spot for each one. So that way I get rid of my decimal. So I'm going to end up with 8t minus 8t squared minus 80t plus 192 equals 0. Now all of them can be divided by 8, so I'm going to get the 8 out. I'm going to have t squared minus 10t. It doesn't look like a 10, so 10t plus 24. Now after a factor, there's not a lot of room here, but let me move around. After I'm done factoring, so I'm going to have the 8 still out in the front. And if I factor, I end up with t and t and 6 and 4. Because 6 times 4 is 24, but they add up to be 10. And my signs are negative plus, so that means my signs will be negative, negative. That means that my answers are t equals 6 and that t equals 4. So 6 seconds and 4 seconds. Next problem. What is the maximum height of the ball that the ball will reach? So I know that my parabola is going to open down. And the reason I know that is because my first number on my problem is a negative. So that means it'll open down. and that means I will have a maximum somewhere up here. Now, I also know that my maximum will be between 4 and 6 on the number line. The number that's between 4 and 6 on the number line is 5. So I already know part of my vertex, which is going to be 5, comma, some y. Now, I can use the simplified version here that I used here to find out where my 5 will be, or I could take the 5 and plug it into the top problem. So I think that's what I'll do first. So I'm going to plug in negative 0.8 and then t is 5 squared plus 8 times 5 so that I could find my y value. So once I plug that all into the calculator, I find out that my y value is equal to 20. So that means that number goes here. So my vertex is at 520, which also happens to be my maximum. And I've answered both the questions. Now let's go look at number 64. We had talked about this before, where we want to make sure that these two match, but right now one of them is not matching. So obviously this one is not matching and this one is x minus 5. So, but this red one is backwards. So in order for me to flip it around so it could look like the other one, I need to take out a negative. So I'm going to make this x into a negative. And then what will happen is that this red one here will turn into x minus 5. And I still have my y, of course. And over here I still have it the same as x minus 5. But now you can see that these two green highlighted ones now match. So I'm going to rewrite them once. X minus 5. And the red and the black there that's left is negative x minus 3. And all of this will equal to 0 because we want to try to find zeros. The first one's pretty easy. X equals 5. And the next one, if it gives you trouble, just set it equal to 0, add the 3, negative x equals 3, but then this negative will turn that into a negative, so, or this negative will change that sign. So that means my other answer is x equals negative 3. And those are my zeros. Okay, we are going to try that again. So we're going to change this to a negative 7, flip this around, keep this one the same because I already have the x, and then the minus 4, I have the letter first. The whole thing will turn into a 0. Those two parentheses are matching, so I'm going to write it once, and then I have negative 7 minus x, and all of that equals 0. So my first one is x equals 4. And my next one is negative 7 minus x equals 0. So I can take this x and move it to this side, and I'll have negative 7 equals x, and that's my other 0. If you want to turn that one around because you want letters to the left and numbers to the right, you can. It's the same answer. And this concludes your review. I hope you got all the help you needed and that you do really well on your test tomorrow.